What's up? It's that time again. We're going to do another new video. This time we're looking at generative design. So for this video, it's going to be less of a tutorial and more of a first look. So getting you hands-on with it is not something that we're going to cover in this video. But what I really want to do with this is show you how the tool works, how it is that you do stuff with generative, and then how you might manufacture afterwards. So just like the previous set of videos that I did on the coffee table, I am going to make some stuff from generative, but you got to bear with me because it's going to take a little while. Some of the stuff's really expensive and, well, got to wait until I got budget. With that said, let's jump right in. I think you're going to really love this. Okay, so for this first look video, we're going to use this skate truck. You've probably seen some of the renders that I've posted up on Twitter or on LinkedIn, and I'm going to show you how I made it. So for this exercise, what I did was I focused in on the hanger, which is this part of the skate truck. So getting this ready for generative requires a little bit of setup. So I have a separate file over here with my setup. Now, when you're designing with generative, you have two things to remember. You have obstructions and you have preserved geometry. So preserved geometry is essentially where it is that you want things to be connected up, where it is that you want the focus of your geometry to be. And the obstructions are, well, they're obstructions. They're there to prevent the geometry from creeping into areas where you need to keep it clear. So in my case, I have a few different obstacles. I have this volume that I've created here. This is to maintain the shape of the truck, but also because I need these cavities clear so that you can lean left and lean right to steer the board. Some of the other obstacles in here are the wheels, as well as the kingpin and the bushings. The preserved geometry in my case are the three pieces that I created here for the axle, the connector here for the bushings and where the kingpin drives through, and then the little point here which connects to the base plate. So with this done, I would hit generate, and remember, for the time being, generative design features are Windows only, unfortunately, but it will be coming to Mac very soon, so keep an eye out for that. Jumping over to generative, this is what we have. These red areas are my obstacles and the green areas are my preserved geometry. And the first thing I would do is go through and add my constraints. You can see that I've already got my fixed constraint here. Then I would add my loads. Then I would tell it what my objective is. So your objective with generative is one of two things. Are you trying to minimize your mass, or are you trying to maximize your stiffness? In my case, I'm trying to minimize my mass and I want to work to a factor of safety of 2. Next, I would go over to manufacturing. In the case of my studies, I've done them with unrestricted and additive. With the additive manufacturing restrictions, I've told it that I don't want overhang angles at below 45 degrees, and I want my minimum thickness to be 8 millimeters. So minimum thickness here is not referring to shell or wall thickness, but actual element thickness. That's basically saying that you don't want geometry that is less than 8 millimeters across, because, well, it depends on the limitations of your printer. Maybe you can't get something that small. Maybe you know that if you print something smaller than a certain thickness or diameter, it's going to break. So in my case, I've set it to 8. It's nice and healthy. It means that I know that I'm not going to end up with anything super skinny that might damage my final design. And then you need to tell it what materials it is you're working with. Generative, of course, is using physical constraints and a lot of calculations in the back end to make stuff. And it's based upon a real-world material. So in my case, I've chosen 2 casting materials, stainless steel and titanium. And then again down here, I've used the NetFab additive materials, stainless and titanium. Now with that done, you would hit generate, and then you could go over to the Explore tab. I'll jump to that one in just a minute. You can see different results here. I have a few that have converged, a few that have completed, and then a bunch of these that just flat out didn't work. This was when I was running a study to see if I could build a skate truck out of aluminium instead of steel, and you know, of course, it's not really going to work. Once you're done, you can pick different designs. So just so you know the difference between a converged design and a completed design, a converged design is when it has met the exact goals that you've set. So you've got a factor of safety of 2, and it's also manufacturable from the different processes that you've chosen. If it says completed, like some of these designs down here, that means that it is in fact manufacturable, but it hasn't met the goals that you've set. It's more than likely exceeded them. Anything else would just end up down here. So in my case, I ran this a couple of times to see different results. My load cases, if I jump back over here, you can see I've got 4 different load cases. For me, I have just kind of a standard, I'm rolling down the street, I'm leaning left, I'm leaning right, and then a sudden impact for when you land a trick. So those are the different load cases because those are the different kind of scenarios that the skate truck would be under. After that, this is the design that I ended up with finally, but there were a couple of extra steps before I got to this. So when I ran this the first time, I pulled out a design and I got this. It works, but I feel like it could be better, and the design's just a little bit odd. So what I did was I took this into Mesh Mixer and I produced this lattice. And then I took this lattice and I brought it back into my Generative Design setup. So over here in Study 6, if I go back to my definition space, and let's close a few of these down. If I jump to Study 6, you'll see that lattice in here. And I use that lattice as a starting shape. So what a starting shape does is essentially tell it that you want to start with this and then run the generative process again. And that's basically going to just essentially take that as your starting point rather than it trying to connect everything together on its own and then run the algorithm again. If it does it that way, you end up with essentially just a feedback loop. So in my case, I ran that, and that's how I ended up with this. Now, it's important to note that generative isn't going to automatically produce something that's symmetrical and aesthetically appeasing, because it's going to focus exclusively on matching and meeting the goals and targets you set in the setup space. So with this, what I did was I hit export and grabbed myself a SAT file, which I then brought back to Fusion to here. And then inside of Fusion, I actually split this in half and mirrored it across to create that symmetry. The final stage for me on this is to run an FEA analysis to make sure that I'm not basically ruining things by cutting it in half and reflecting it this way, but it should be absolutely fine. We'll find out very soon. I fully intend on manufacturing this, so I'm going to be printing this in DMLS, so I will be using direct metal laser sintering. I'm also going to print it in PLA and then cast it, and we're going to ride these. And the point behind this is really just to demonstrate that you can produce production grade parts using 3D printing processes. 3D printing is no longer simply a prototyping tool, but it is something that you can use for final manufacturable parts. The reason I've chosen a skate hanger is, well, a skate truck is probably one of the most beaten up and tough parts out there. It's got to deal with some really extreme situations, and so the assumption is that if you 3D printed something like this, it would immediately shatter the moment someone tried to ollie or grind it. I intend to demonstrate that that isn't the case, so watch this space and you'll see a video very soon. But that's it for this. Hope you found that useful. Alright, well thanks guys, I hope you liked that video. Don't forget to hit that like button, subscribe if you haven't subscribed before and you want to see more of this content. And don't forget to leave me a comment in the comment section below. Let me know what it is you want to see more of. Tell me what you liked, tell me what you didn't like. Let's keep the conversation going. See you later.